So I'm Leonardo Angelini. I'm from the University of Applied Science of Western Switzerland, and I'm presenting this paper, which is actually a work of a master's student from the University of Rome who came in internship in Switzerland, and so we collaborate together with the Sapienza University of Rome and as well with the Ex-Ianni Liverpool University. For this work, I mean, the title could be a bit buzzy about how we can reach the metaverse with emotions. Of course, this is just a little step towards this direction, and I hope that this framework could be useful actually to design some scenarios where actually emotions in the metaverse can be useful. So you know about the metaverse, we spoke about it already before, and you might know as well that Zuckerberg renamed the Facebook company as Meta with the goal of monopolizing somehow this world where you can actually experience many things. Right now they have a tool, for example, for collaboration, and there as well it could be useful actually to have emotions and have scenarios where you can actually promote activities that can elicit emotions inside the people that are experiencing this metaverse. At the moment there are not many possibilities to track emotions, but we see that in some devices we start to have, for example, eye tracking, and also to have facial expressions recognition, mainly for building avatars. But as we have seen in the previous talk, this could be useful as well in order to recognize emotion and give feedback eventually and augment in this virtual reality the possibility to show emotions or what it is recognized. There is as well a new device which is including EMG sensors and EEG sensors inside, and add-on you can add actually in the headset. So there are things going on in order to measure emotion through physiological signals, and as well through cameras embedded in virtual reality headsets. So we think that there are many possibilities in the future in order to design better experiences that can elicit emotions in virtual reality or in mixed reality. So we wanted in this context to build a tool that could help designers of virtual reality scenarios to collect physiological data and analyze if their scenes that were designed, their scenarios were effective in terms of possibility to elicit emotions. And in particular, we want to identify a way to collect these physiological sensors in as much as possible intrusive way, for example, by using a wireless sensors, and in particular to synchronize the data, the physiological data, which is what actually is going on in the virtual reality scene, and as well with some video recording from an external camera to see if the reaction of the person to the VR scene was effective or not. And so as much as possible then to record all this data and eventually annotate events that happens to go back and check what happened at this specific event that you want, for example, to assess in these virtual reality scenarios. And then we wanted also to make it simple to use to people who are not acquainted with physiological signals, for example, or with computer science tools. So this is the architecture of the platform that we designed, and it is made of different components. Of course, you have a virtual reality headset to make this experience happen, and we use actually Unity in order to design any kind of virtual reality scenario that could be played in this virtual reality headset. And we want to have wireless sensors to detect the physiological signals, and as well an external camera in order to record what was going on during the experiment. And then we designed this application in order to visualize the recordings in real time, and as well to take the data that were recorded and play back what was recorded in order to study if particular scenes were effective. And eventually then you can add on top some tools like machine learning tools in order to analyze the data. And for choosing actually the sensing platform, we use the Biosignals Plus Hybrid 8 module, which is very nice because it's Bluetooth, so you don't need to wire physically the person to a computer in order to collect the data in real time, but everything can be actually streamed by Bluetooth. And then you can plug in many different sensors, for example, accelerometers, ACG, AEG, ADA, AMG, so many different sensors that can be used to detect different emotions during virtual reality scenarios. So we tried to compare what we wanted to achieve compared to other tools that we found in literature. This is not extensive, of course. Many other studies use actually a physiological signal in VR. I found a systematic literature review who found 1,000 studies mentioning virtual reality and physiological data. But the idea is that we wanted to include as many sensors as possible in order to give flexibility to these people to analyze the scene from these different point of views. And as I said, we wanted to make it wireless. At the moment, still, we need to be wired to the headset because we use an HTC Vive headset, but maybe in the future we can find a way to use also wireless headsets with our solutions. And then, of course, we can design any scenario we want inside Unity. And we have the possibility to sync the data that we collect through the sensor with the video that is annotated as well. So from what we have found, we couldn't find it since now a platform that is so complete. But in order to understand what's the platform talking about, we'll show you a short video tutorial for the system. Do you hear the audio? But you don't see the video actually. I don't know why.
I can't see the video.
Okay, now you see it?
No.
You don't see it. Why see it? You see it? No?
Yes, yes.
Okay. Do you hear the audio?
And the audio is not there, but no, only the video. I think there's some problems with playing audio on Zoom, so just try to explain.
So I can comment myself, yeah. So the idea is that you need to configure actually the position of the sensors in the device, and then you can start the recording inside the application. And then you can see the sensors flowing, and then on Unity you can also start the scene and then start the scenario with the user that is going to experiment something. In our project, actually, we tried this framework in order to assess eventually if we can detect fear, and specifically we designed a sort of dungeons where at some point a monster was appearing and screaming loud while the person was actually looking for a key inside this dungeon. So when the person found actually this monster, actually we will see there will be a huge reaction, and then maybe we can see some reactions in the physiological data. And so then you can stop the simulation, the recording. Now you can actually go in the offline mode and then take the data that were recorded, and then we asked participants actually to find again the event inside the recording to see what was going on. And it was a task that we actually assessed with the users. So you will find the folder with the recordings, and then you can see the recording of the VR scene and as well of the camera and the different sensors. Okay, so this is actually the dungeon. Unfortunately, you cannot hear the music, but there is like immersive music for the person going around. Then you walk, and then at some point you are going inside the room, and in this room you will find the monster coming out loudly. Unfortunately, you cannot hear the audio, but I can assure that it's scaring.
We heard it at the end.
Ah, you got it. Okay, so
I was scared actually.
Okay. And this is actually some reaction, and you can see actually some people that react in different manners. This is quite smooth reaction. And in some case, we had also some huge reactions, actually. The person completely scared. So you can see that actually from the reaction, you actually see that people tend also to jump. And so what we actually did is that we focused on different sensors to see what was the reaction. I see that Min is also scared. And so the interaction lasted about 2 to 3 minutes, and we recorded all this data with 15 people. And then we used the accelerometer sensor was positioned on the chest. We had the heart rate, the electrodermal activity, and then you have seen we have placed some EMG electromyography sensors on the neck because we expected that the person is contracting in respect to the fear. And then we had also the respiration rate sensor. And as well as you have seen, we have an external camera with whom we show the recording, and then the recording in Unity to synchronize what was happening actually in the virtual reality scene. We actually tried to understand if this interface is easy to use for non-expert users. And then we tried as well to analyze these recordings with non-expert people, actually also 15 people. We asked them to actually find in these events the monster appearance event in the raw files, and eventually tell us at which moment it occurred, either in the raw files or to find this event with our tool, so to see everything synchronized inside our tool. And we have seen, of course, that it was easier to find the event actually in our tool and faster as well. Of course, this was also a very short recording, so 2 to 3 minutes. Imagine if you have a much longer recording, then this could be even could have even a bigger effect. And then we measured also the system usability scale in order to understand if the tool was usable, and actually we found a score of 76, which is something that we can consider as good. We also analyzed the data with some very simple analysis of the recordings, and then we found out that we could actually detect the spikes in the recordings, especially in the EMG and the accelerometer. And by comparing the timestamps that we annotated manually and the data analysis through the peak analysis, we found that in 8 data sets, we found spikes in both EMG and all 3 channels of the accelerometer, while in 3 data sets, this was evident in 3 of the 4 channels, while in 1 data set, this was evident just in 1 channel. In the other 3 data sets, we found actually no matching. This could be caused by artifacts, for example, a participant that had eventually overreactions and then were moving a lot during the other experiences, or eventually by people who had very calm reactions to the the event. We also analyze ADI and HR data, but of course, this is something that you couldn't really do with peak analysis, and there is a lot of difference between different participants. And of course, we need more detailed analysis, maybe with machine learning, in order to find differences between before and after the events. So to conclude my talk, we have seen that we had a platform that was easy to use in order to record, annotate, and play back VR experiences. And we think that this could be beneficial for designer of VR experiences in order to assess from the physiological point of view, eventually the arousal that some scenarios designed for VR were if they were effective or not. And the benefit of this platform is that you can easily sync the data from physiological signals and also from RGB camera and the VR recordings. Of course, there are improvements that are needed. You can also, we need to, for example, add the possibility to zoom inside the physiological data. At the moment is static in a determined time lapse, but I think that this is something that could be useful. And then, of course, we can improve as well the UI. But at the same time, we want to make this application evolve, and it would be very interesting to use a wireless headset as well, so that the person could be free to do the experiment without being attached to a computer. This could be a bit tricky because the Oculus Quest doesn't have the possibility to collect data from Bluetooth, but maybe by synchronizing data with a smartphone, this could be still possible. And we are exploring actually as well the online recognition of affected states. I will show you something that we are currently doing in other studies. We have a study in automation, in semi-automated vehicles, where we want to collect the affective state of the driver in order to know if it's a good moment to get back the control for takeover over automated driving. And now we actually used online recognition with Python in order to recognize different states of the driver. So it would be possible actually to combine the two systems in order to do automatic analysis of affect states. And we also designed a new system where we are actually adapting the VR content based on the emotion or the affect that is recognized by the person. For example, we designed a scenario for post traumatic stress disorders, especially after car accidents. And so we simulated like a scary situation where you are close to do an accident to see if the person is reacting, and eventually provide the same stimuli in an increased manner. So in a way that you increase the difficulty of managing the stressful situation, for example, during traffic while you are driving. This is something that is ongoing. The framework is actually available on GitHub, on our GitHub. And so if you're interested in working with us, please make contact with us, and we are also open to answering